Hi guys, welcome back to Data Every Day. Today we're looking at a dataset of video games and their ratings by the ESRB. Um, and you can see each feature is binary, basically a yes or no about a certain type of content that's within the game. And at the end of these 33 features, we have a target column that is the ESRB rating for a given game. So it doesn't seem to be loading, so let's hop into the notebook. I'm going to use NumPy and pandas for working with the data, and for pre-processing I'm using the train test split function and standard scalar from sklearn. Then we're going to use a whole bunch of different classification models and compare the results later. So we have logistic regression, k-nearest neighbors, decision tree. We have two support vector machines, one with a linear kernel and one with a nonlinear kernel. Then a neural network, and then the rest are our ensemble methods. They are all tree-based, I believe. So let's go ahead and import all of that, and we can load in the data using pandas.readcsv. Now we have two different data sets here, and today I'm going to show how to if you have a train test split already made between two different CSV files, how can we pre-process them separately using the same function? So we'll load them both in. I'll use traindf to load in the train set. I'm using pandas.readcsv for each of these. That's going to be our train set. And this, I'm going to do the same thing for the test set. So this is testdf, but I changed the file path to this one. So paste that in, and we've loaded in the data. We can take a look at traindf, and you can see we have the title of the game, and then all these binary features, and then the ESRB rating at the end, and this is what we're trying to predict. So I feel like we have a good number of features for making this prediction. Hopefully we'll get some good results. We can get a little more information about the dataset with traindf.info. And here we can see there are actually no null values in any of the columns. The same goes for the testdf, so it's nice and clean. We also don't have any object columns. Everything has been encoded, and we're only dealing with binary variables here. So let's start pre-processing. Okay. So I'm going to create a function called preprocessInputs. And usually what this does is it takes in, what I usually do, is it makes a copy of the data frame, and at the end it's going to return all four sets of the data after making the train test split. So it will return xtrain, xtest, ytrain, and ytest. But in this case, we're actually not doing the train test split because we have the split made for us in the files already. So for now, I'm just going to have it return a copy of the data, return df, and we're going to store that in x. So we'll pass in data, and we'll get back x. Sorry, it's not data, it's traindf. So we can get x via traindf, or we could also pass in testdf. You can see that either one will send it through this function. So what I'd like to do, because I have the train test split outside, I want to specify a parameter called split. And this will be either train or test. By default, I'll have it on train. And what this will do is help the function know if we're coming in with a train set or a test set. First thing to do in either case is to drop the title column, because the title column is not going to give us any useful information about the data, right? About the examples. There's no way to, because they're all unique, they're unique identifiers for each example, there's no way to draw differences, similarities between different examples. So we're going to drop it with df.drop title. And we're dropping from axis 1, which is the column axis. Then we're going to shuffle the data. And usually I leave this step out because it's already included in the train test split function. But today we want to shuffle it before we make the split into x and y. We want to make sure that we do this first so that the x's and y's are shuffled together. So for this we can use df.sample. And you can either specify a number of items to sample, or you can use the fraction argument, which specifies what percentage of the data we want to sample, what portion. So we're going to use 1.0, which just means sample all the data without replacement. and we're going to include a random state just so that we can reproduce this shuffle whenever we like. And since we're shuffling, I want to reset the indices after, and I'm including drop equals true so that the old indices don't become a new column. So if I run this now, we should have a shuffled data set. So you can see, just to verify, right now if I run this 2 times, we'll have the same 1, 1, 0. But if I was to change the random state on this, then we shuffle it, it will be 1, 0, 1, it will be something else, right? So just to show that we are shuffling. Now we can split. So I'm not doing a train test split. I'm just going to split the data frame into X and Y. Y is what we're trying to predict, and this is going to be the ESRB rating, which is all the way at the end. It's the ESRB rating column, so that's going to be df sub ESRB rating. Now X is all the rest of the data, so we drop ESRB rating from axis 1. And now we're going to return X and Y. Now we get them back over here, and X no longer has the ESRB rating column at the end, and that's being stored in Y. So now we want to scale, and if you know my videos, usually I stress the importance of scaling only the train set, fitting the scaler only to the train set, because you want to sort of pretend you don't have access to the test set at the time of pre-processing. So when we scale X, we want to know, are we dealing with the train set or the test set? And that's what this is for. Now we actually also want to pass in a scaler along with the data frame, because we want this scaler to maintain its fit outside of the scope of the function. So the scaler has already been created for us, and we're going to say if split equals train, then we'll fit the scaler on X. Now in either case, whether or not it's train or test, we will always transform X using the scaler. So that's outside the if statement. And so in the case of a test set, we don't fit it, we just transform it. And in the case of the train set, we transform it after fitting it. Now, this requires that we call this function on the train set first. Otherwise, when we do the test set, we'll try to transform using an unfit scaler. So I would like to point out that if we're running this, let's pass in a scaler. I will create one up here, which will be a standard scaler that will give each column a mean of 0 and a variance of 1, which will improve the performance of many models. And we pass it into our function along with split equals train. And you'll see X is now a NumPy array. So it has been scaled, but I can't see it like a nice data frame, so I'm going to turn it back into a data frame afterwards. And I'm going to keep the indices the same as they were, and the columns the same as they were, like so. Alright, and here's the scaled data frame. We can verify that it's been scaled by checking the mean, and all the means are very close to 0, and the variances are all very close to 1. So now what I want to do, after we've run this through, is well, actually the function is done. This is all we're going to do to the data, but we want to return all 4 sets of the data down here like this. Xtrain and Ytrain are going to come from the function passing in trainDF and specifying split equals train. And then down here, we're going to have xtest and ytest, which are coming from testDF, and we specify that the split is test. And this will ensure that the scaler is not fit on this data. So we run this, we take a look at xtrain, we take a look at xtest. Both data frames were passed through the same function, but these the scaler was fit to this data and it was not fit to this data. So it scaled this data using the fit it had on xtrain. Alright, and then ytrain is just going to be the labels for each of these examples. Alright, and let's start training. So I imported a whole bunch of models like I showed before, and for the sake of time I'm just going to paste in this dictionary that maps the name of the model to the actual instance of the model. And this is a nice way to try out a lot of different models if you just want a quick idea of how different models are doing, because you can then iterate through for name and model in models.items, and .items will return the key value pairs of a dictionary as tuples, so that you can iterate through 2 at a time like this. And we can fit the model on the train set, and we can print out a little confirmation message using the name that said that the model was trained. And I did specify just a few arguments in here to keep this print statement from getting muddied up. This was throwing in a warning, and this was showing a whole bunch of training information I didn't want. Alright, so now let's see the results. So all the models have trained, and we can now easily see the results by again iterating through for name and model in models.items. We're going to print out the name of the model, followed by the accuracy value for the model. So I'm going to say accuracy, and we'll display the accuracy to 2 decimal places with a % sign. Why don't we make it 3 decimal places. And I'm going to format this with model.score. For a given model, the score function will return the accuracy when the predictions on xtest are evaluated against the actual labels in ytest. And since this is returning a percentage, I'm going to multiply it by 100. And here we can see the results. So, pretty good. It seems like all the models are doing roughly the same kind of, we're getting the same kinds of results for each model. So that's interesting. It looks like, yeah, there's not too much difference. They're all right around 83%. Some of them are a little higher. It looks like XGBoost has the highest, but it's tied with the Random Forest. And then all the others are falling shortly behind. So at this point, I might experiment with different hyperparameters of different models. Maybe I'll take the best performing models and do a grid search for their hyperparameters or something like that. But that will sum up today's video. So thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.